Hello. Today we are taking a look at lesson 18.1. We're still talking about polynomials, but 18.1 specifically is where we are multiplying polynomial expressions by monomials. Remember, a monomial is one term. All right, so this is the type of problem we are looking at. See, I have my polynomial expression here, and that polynomial expression is being multiplied by this monomial. This is just a fancy version of our distributive property. Okay, that's all it is. Fancy version of our distributive property, which means that we are going to multiply our coefficients. Remember, coefficients are the numbers sitting in front of your variable. And then because we are multiplying, we are going to use our exponent rules. That tells me when I multiply powers, I add the exponents. So in order to simplify these problems, we are using the distributive property, and that means we will multiply coefficients but add the exponents on the like basis. So let's look through just a couple. So this is that example we had just a moment ago. I'm going to show you what this means. Remember, it's distributive property. So here it is broken down into parts. Okay, what we're doing is I just worked it out instead of just showing it like I would normally show a distributive property problem. Okay, what I did with my lines is the same thing here, showing you exactly what's being multiplied. Again, my coefficients can then be multiplied, and my exponents, because they're like exponents, can be added. Remember, that has an exponent of 1. So multiply and add. So 12 times 9 is 108. 5 plus 4 is 8 to the ninth. 12 times 4 is 48. 5 plus 2 is 7. 12 times 5 is 60. 5 plus 1 is where the 6 came from. There are no like terms left in this problem, so we are at our simplest equation, or expression, sorry. Okay, again, remember when you're multiplying distributive property, multiply coefficients, but because we are multiplying like bases, we can add their exponents. So 6 times negative 4 is negative 24. 3 plus 4 is 7. So negative 24, x to the 7th is my simplified answer. Same thing here. The big thing that you need to be careful with is this x does have an exponent of 1. All right. So that had an exponent of 1. This x also, remember, has an exponent of 1, as well as our y. So now we can go in and we will multiply our coefficients, and then we add the exponents of the like basis. So I have the x's, and then I have the y's. So here's what our final answer would look like. All right, so then that is our simplified answer. Take a look at another example. So don't get overwhelmed. I know it's easy when you look at problems like this because of all the exponents to get overwhelmed. Remember, you are matching bases. Okay, so the first thing I notice is that z does not have a visible exponent, so I'm going to go ahead and add a 1 in for it. Pardon the noise. Now, my coefficients can be multiplied. Everything with a base of y, I can add those exponents. Everything with a base x, I can add those exponents. And then everything with base z, their exponents can be added as well. And we will write our final answer in standard form, which means I'm going to put my variables in alphabetical order. So 18 times 3 is 54. X's have exponents that add to 11. Y has exponents that add to 8, and z has exponents that add to 5. This is my simplified monomial answer. Okay, taking a look at another one. The common mistake here is again forgetting that this has an exponent of 1. This has an exponent of 1. Okay, so we are distributing to simplify this problem. Coefficients can be multiplied. Exponents will get added. So I have 9x to the third for this first part. And then I come down here and I have 3x times 6x, which would give me 18x squared. And then 3x times that 5 is that 15x. Okay, taking a look at another one. Again, I like to go in and anywhere I see just a regular variable, add in a 1 just for visual. You do not have to, but it definitely helps me remember that it has a value. So now we are distributing. Okay, so showing what we're doing. So I have to add my x exponents and my y exponents for each problem. So 2 times 5 is going to give me 10. X to the first times x squared is giving me x to the third. And then y to the first times y to the first would give me y squared. Okay, and then I go through and I do that for each term inside those parentheses. So we get a simplified answer of this. Again, nothing here is exactly the same. Even though I have x and y's in all of them, all of the exponent variations are different. So this is our final simplified answer. All right, let's take a look at one more. So again, it's, I know, easy to kind of be overwhelmed when you see a problem like this. Remember the process, okay? The first thing I'm going to do is I like to go in and fill in with that exponent, completely optional step. Now what this means that I'm doing is I am distributing, multiplying coefficients. Those are our numbers sitting in front, and adding exponents of like bases. Okay, so all my A's will add our exponents and B's will add our exponents as well. So once you've done that multiplication, you should get an answer of this trinomial. Okay, again, I know it seems a bit busy, but this is our simplified answer. There's nothing else we can simplify. So I'm going to pause the video here. If you need to, continue to work through the rest of the examples in your PowerPoint. Remember, multiplying a polynomial expression by a monomial means that I am multiplying my coefficients, adding exponents to my like bases. Please reach out if you have additional questions.